So if you're setting up a simulation for this scenario, you can get $0 80% of the time. So we're talking about the percents, right? So I already know I'm going to be running. You could do this one of two ways because we're going to be dealing with a random number generator, a random digit table. And we're going to be using 2 digits in a row. So these are my 10 digits that I'm underlining right here. And it doesn't really affect much in this scenario, the way it was set up.
I've got a quick question real quick.
Yeah, go for it.
So I understood that we were using percents for the thing, but so like if there's a gap, since like I saw that each numbers were like in sets of 5, and you're going over like the 8 goes to 3, the 7 goes to 8, right? Can you do that for all situations with percents or just this one?
8 goes to
like so there's like for the like you're using like sets of 2, right?
Oh, I'm with you. Okay, and the 6. Oh, so the 8 goes to 3. Are you talking about this right here?
Yeah. So like, can you do that for all number sets, or is it just like when you're using percents?
Anytime you need to get 2-digit numbers, and so with percents, it's always 2-digit numbers. But the scenario we were looking at yesterday, where we had 1 to 95, that was still 2 digits. If we had gotten 96, in fact, one of our numbers right here is 97. That we would have just thrown it out. We would have skipped it. We would have said, okay, we were at campsite 67 today. We skipped 97 and 89.
I see. Okay, thank you.
Yeah. All right. So as far as this scenario, you could start at 00 to 79, and that would be your first 80. Now, the thing with, and we didn't talk about this, so this is something you kind of had to reason through. You would have got the same answer either way, but you need to decide, are you going to start at 1 to 80? And then what does that 00 represent? We don't see any here, but if you did happen to get a 00, is this going to represent 0 or is it going to represent 100? And, in some cases, it's actually easier to think of this 00 as 100. That way you can just kind of start at 1. Otherwise, you always have to, in your head, you mentally subtract 1. So anyways, my first number I'm going to say is 1 to 80. So that represents the 80% of the time that I'm going to get no money. And then I'm going to go 81 to 95, which represents the 15% of the time that I get $1. So 0, 1. And then I could win $20 or $50. And this is going to be from 96. It's 3% of the time. So that's going to be from 96 to 98. And then the rest of the time, that represents 2%. If you do the math, so that's 99 to 100, and I'll just put to 00 right there. All right, so if I look through, I got no money right here, so that's 0. 51 represents no money. 83 represents $1. 67 represents no money. 97 represents $20. 89 represents $1. And then no dollars, nothing, and nothing. So it looks like after the simulation, my cumulative total is $22. All right, so that is how this simulation would have gone. And hopefully if you didn't get that or you weren't on the right track, hopefully you see where you went wrong. All right. So we are going to go over chapter 12 today. Just so you know, in general, my goal, I added a few days to this for this semester because we have more days in the second semester. But because of the snow days, I figured we'd get back onto our regular calendar. So I'm actually taking those extra days out of this unit, which you're not losing a day from what last semester students got. You're just going to be kind of spending the same number of days in this unit, if that makes sense. Anyways, we've got today, Thursday, and Friday. I believe Monday will be when you take your test on this. And then we'll be back onto the calendar that as it is in the syllabus. Okay, let's start with chapter 12. This is going to be a lot of just me explaining some concepts. This is a very conceptual chapter. If you read it, you're already aware of it, but there's not anything related to calculations with this. It's all conceptual. Okay, but there are some vocabulary we need to be aware of. So a sample, that's what we're talking about today, sampling, where a sample is drawn from a population of interest. Now, if you did happen to survey everyone in the population, it's called a census, which is why every 10 years we do a national census in the United States. So a sample might be collected and given a sample survey, which has questions intended to help researchers learn more about the population that the sample represents. So if the sample doesn't match the population, then the results could be biased. We're going to get to bias later, but let's just start by saying that if your sample is not representative of the population, your entire analysis is worthless. So you need to make sure that sampling is, it seems simple enough. It's like, oh, I just want to ask these questions. I don't care. I'll just ask these people. But if you don't get your sampling right, then nothing else matters. All right. Sample statistics. So we've already talked about this to some degree, but we have sample statistics, which come from random samples and are used to estimate the population parameters. So just to clarify what that means, I could sample everyone in this class to find out your favorite, or I don't know, just something really innocuous here. What your grades are, throughout high school. Now, if I looked at all your grades, that would be my sample statistic. I could average like what % score you got for your classes. Now I could use that to estimate what the overall school got. Now, of course, we could debate later whether that would be a representative sample or not, but whatever I get from my sample, that's what I'm using to estimate for the population. And that's pronounced, they give something weird here, but mu. So I don't know that mu, but mu. Anyways, your standard deviation that you get from your sample could be used to estimate what the standard deviation is for the population. Now there's a correction we make for this. We'll get to that stuff later. That's not something we worry about till next semester, really. Next quarter, I should say. Since taking a census is time consuming and costly, usually we get samples from the population, and there are also issues with censuses, censi, that matters. Sometimes the census doesn't actually reach everyone. We get this false sense of accuracy. All right. You never get 100% participation, so you could be missing parts of the population. And this is something in the book. If you are trying to get a census and you're trying to get everyone's opinion, well, new information could come out from when you start the census until the end, and thereby you're not getting a real accurate picture. So you want your data collection to be as quick as possible. All right, so let's gonna pretend that we have a scenario here. Let's pretend we're all interested in whether we should come back, like the opinion from our student population on whether we should come back to school after the third quarter. All right, so let's pretend that's our scenario. Knowing only what you know now, how might you go about designing a survey and gathering data to make sure you can accurately gauge how people feel? So are we going to do breakout groups? I want you to think about that for a minute, and then maybe you guys could share if you have any ideas of how might you get a survey designed and sampled. So we're going to talk about different sampling methods to start out with, and we're going to end by talking about where bias can come in and what you want to avoid. So actually, I guess we're starting with what you should avoid, but there's other bias that we're going to introduce later. So convenience sampling. This is the laziest form of sampling. So if I was trying to get people's opinions and I was being really lazy, you guys are right here, right now. I could sample you guys. It's minimal effort. I could just ask you guys what you think, and what population am I trying to represent by asking you guys? Maybe the school, all right? But it must be drawn from a random sample. A convenient sample violates that principle. It's not random. You guys are here, so you're not randomly here. You signed up for this class. So anyways, I need to randomly pick people from the school. And any results that I got from a random sample are suspect at best. You guys, I imagine, would already kind of be suspicious of, taking our opinions in this room and projecting them to the rest of the school. So we do not want to do a convenience sample. Well, I kind of already answered this, but I already threw this out there. But if I was trying to figure out for the school, should we come back after the third quarter, what could my convenience survey look like?
Just us in here.
Ask in here. And I mentioned that one. So very good. Now, if I asked you guys to go out there and do this survey, what would a convenience sample look like once you got out of the classroom and you were just sitting at home? What could you do?
Just ask
Talk
like,
to our family
members.
Talk to family members, so what did someone else say?
Your household family members.
Household family members. And you all are still connected with friends. So if you just went to your friends that you're close with and asked them. So we get the idea, I think. Don't do this if you're trying to get a real result. And actually, it's kind of funny whenever you see people who will have like letters to the editor and stuff like that, and they'll say, I talked to 100 people and asked them what they thought about this. And it's like, yeah, which 100 people did you talk to? Anyways, voluntary response. Here's another thing that's kind of a no-no. If the only survey participants are ones who volunteer to be part of it, the sample could be biased toward those who are passionate about the subject matter. So a truly representative survey includes people who are not excited to participate. They're kind of roped into it. And what would a voluntary response survey look like for a question of interest? So most of them would have similar responses. And yeah, so that could be like the outcome of a voluntary response. So here's one example I have, and we could kind of think about this more. I used to, luckily now I'm not apartment hunting, but one day you might be doing some apartment hunting, and they have all these apartment review sites, and people can rate their apartments. And what do you think the reviews look like at apartment review sites?
Like really bad or really good?
Right. And primarily really bad reviews. And why do you think that is the case? I'll just answer it. You can probably imagine. But the people who had like a really bad experience at an apartment are going to go and review it. And the people who, I lived at a few apartments in my life, and I just lived there. I moved away, and I didn't care much about it, right? So I'm not going to go and review and say, it was great. But if I was really, really upset in an apartment complex, I'm going to go online and leave a bad review. So that's voluntary response. And you end up not really getting the big picture that's representative of everyone who lived at those apartments. So if we were going to do this, I'll just answer this because we have limited time on a Wednesday. Like if we just put a poll up on the FHS site, and it's like, hey, there's a poll available at FHS, at the FHS site, go there and let us know if you want to come back to school. A lot of people in this room, even this hypothetical room, will probably be like, whatever, I'm not going to go do that survey. But some people will, because they're like, oh, I really want to come back. So I'm going to go and answer that. And some people are like, I really don't want to come back. And whoever is the most passionate about it, we're going to get most of those responses. But people who don't really care about doing a poll or the answer to the question aren't going to give their thoughts. All right, enough about that. I need to probably speed up a little bit. So what does good survey design look like? So like I said before, you must randomly select your participants in the survey. It needs to be representative, and you need to minimize bias. And you can bias a survey by over or underemphasizing certain parts or characteristics of the population. You're never going to get it perfectly representative, but you want to try and minimize where the bias is. And it must be large enough. And the exact number isn't super important for right now. So you can think of 100 as a good lower bound if you're talking about a large population. Okay. And so now, again, with limited time, we're not necessarily going to take 10 minutes for each slide. But if we're going to try and figure out how to make a random, representative, large sample from our school, we have a lot of different ways we could do it. Let's just focus, let's jump into some sampling methods. Let's not answer that question directly. Let's look at different sampling methods we could pick from. And before we do that, the actual list of people who could be included in our sample is called the sample frame. It's not the same as the population. So the population that of interest for us might be people who live in Flagstaff. The sampling frame is a list of every Flagstaff resident that we have information on. There are certainly people in Flagstaff right now who, if we wanted to randomly sample from the population, they wouldn't even be included, maybe because they're just not on any kind of list out there of who lives in Flagstaff. So the sampling frame represents everyone who could theoretically be included in a sample. This term might appear, it might be important. Typically, it's kind of a smaller nuance. And so just try and remember what that means. There are many possible samples that could be drawn from a population, each including different people. And that's what we call sample variation. So if I picked a sample of 10 people from FHS and then picked another sample of 10 people randomly, then it's highly unlikely I'm going to get the same person twice. But that variation that we get is part of the process, sample variation. That's going to really come into play for the second half of class. But for right now, just be aware that that is a thing. And then there's also called sampling error. Okay, so here are the different types of samples we could do. And this one's the most straightforward. It's a simple random sample. It's also very frequently used. So we just take the entire sampling frame. Let's say we're talking about FHS students. We take the list of every student at Flag High, just get a random number generator and pick different people. So if we wanted to sample 30 people to find out their opinions on coming back to school, I could pick 30 random numbers. If I get any repeats, just ignore that and pick a new one. And I just talk to those 30 people. Every sample has equal probability of being selected. What that means is every possible collection of people who are included in the sample has equal probability. I don't know that I can say it differently, but this is different from our other sampling methods. This is the only one that has this ability, this characteristic. This is only true of simple random samples. So a simple random sample for our question of interest, I kind of already said that. I answered my own question, but we've got a sample, we got a list of all the students at Flag High. We could just randomly assign them, they get numbers and then we randomly pick from there. All right, I'm going to try and stop answering my questions ahead of time. So on the next one, we're looking at what's called a stratified sample. And I guess before we do that, are there any questions on anything we talked about up to this point? Okay. The simple random sample, hopefully, it's called simple random sample. Hopefully you agree, it's quite simple. The stratified sample, if there are, quote, classes within your population and you want to make sure that each class is represented proportionally, you can use a stratified random sample. And the classes are called strata. So if you remember your earth science, we talk about rock layers as strata, so we can kind of split our population into strata as well, and then sample from within those. So here are examples of strata that we use frequently. Gender, socioeconomic strata. Race, age, skill level. You can see the rest, where you are in a hierarchy. So those are typical strata that will come up. And it could be anything else not on this list. Like if your question, if it mattered, you could talk about, what religion do you practice, or none at all, maybe that matters to you. So random samples are then taken within each strata to generate the sample. And you want to make sure those samples are proportional to the population distribution. So if we were, just to give a really simple example, if there's 40% of people identify themselves as Democrats, and 40% identify themselves as Republicans, and 20% are not, or I'll put you for unaffiliated. If that was the case, and I wanted to make sure I got equal voice from all three registrations, then I could pick, if I wanted to have 100 people in my survey, I could pick 40 Democrats, 40 Republicans, and 20 unaffiliated voters. So you want to make sure it's proportional. Okay. Oh, I already had an example. Here we go. So we can just pull that all up. So 50, 35, and 15% represent the different classes in socioeconomic terms in the population. So there we go. For a sample size of 300, we would need these numbers. Okay. Remember, this is available. If you want to come back and get this reference later, you can get that. Now, when we are picking in this case, 45 from the upper class, we would still randomly pick. We would take our sampling frame of all upper class people and then randomly pick from there 45 people. All right. So actually, before we do that, before we talk about cluster sampling, what do you guys think could work for a stratified sample for our question of interest coming back to school?
Like doing students with different extracurricular activities like sports, and then someone who doesn't do sports, someone who has like no attachment to the school and stuff like that.
Yeah, it's one possibility. Did you have something else, Lily?
I was just gonna say, maybe do it by grade level.
Yeah, maybe if we did a simple random sample, we could theoretically end up with only freshmen. Yeah, that is theoretically possible. But if we wanted to make sure we got all 4 grade levels here, we could stratify and then sample within seniors, juniors, sophomores, and freshmen so that we get a representative. All right, cluster sampling is a little bit more subtle. And between these two, this is where the confusion comes in. So in a cluster sample, the population is divided into representative clusters, and then every person, generally speaking, every person in a cluster is sampled. So rather than saying we're going to pick from across the entire sampling frame, I'm just going to take this group of people that are kind of clustered together, and I'm just going to sample all of them. All right, so by way of analogy, and there's another analogy in the textbook, but if you had lasagna, a stratified sample of a lasagna would be to randomly sample the pasta. You go just to the pasta and you pick different amounts of pasta to sample. And then you go to the sauce and you pick that. And then you go to the cheese and you pick that. And you randomly sample from within those different layers. Whereas a cluster sample would just be cutting a piece from the entire pan and using it to represent the rest of the lasagna. So every time you get a serving of lasagna, you're doing a cluster sample of the entire tray there. You can think about that. Hey, it's like I wrote that. All right, and this is a pretty good visual. There are reference posters on the Canvas, in the Canvas classroom, and this is, I think, a pretty good example. So notice right here that we've got these 4 clusters that each represent the population, generally speaking. So now I'm just going to take 2 of these, and I'm going to sample everyone in this block, in this cluster, and everyone in this cluster. And that's what we get. Now that's compared to stratified, where you stratify all your cats, rabbits, dogs, and birds, because that's what you're sampling here, and you pick a random sample from within. All right, so hopefully those two are clear enough in their distinction. The systematic is pretty simple to understand. You just look at your sampling frame. And in this case, I have an example where it's, imagine there's a bunch of product coming down a conveyor belt. You're quality control. And you're just going to take every 50th item off the conveyor belt and include those in your sample. And once you've gone through the entire batch coming down the conveyor belt and you've picked every 50th item, there's your sample. That's random. So let's see what we got here. So if you wanted to have 300 in your sample size and there were 12,000 in the frame, you just divide that and you would get how many people you need to skip. So every 40th person would be the person that you sample. Pretty straightforward. Okay. So if you don't get a perfect number, which normally doesn't come out this nice, just round down so to make sure you get enough. If you round down, you're going to end up with probably more than you need, and that's better. All right, systematic, not too much to that. So multi-stage right here. If you combine if you combine a lot of different sample designs into a single one, it's called a multi-stage sample. This is not very usual, especially in AP or this level AP statistics, but it could be more specialized later on. But we could combine cluster sampling with stratified sampling than systematic. So here's an example. If we're going to try and select people for some particular survey in a city, we could first stratify by zip codes. And then we could cluster sample by selecting 5 census blocks within each zip code, and then every 10th house within the census block. So that's a multi-stage sample that we've done. And if you're sampling a lot of people, that might make sense. So here's also nesting, all right? So if you want to stratify based on gender, then stratify based within that, based on age, and then stratify within age based on socioeconomic status. You can have a lot of different stratifications happening nested inside the other. All right, so I'm going to pause right there because I'm talking and saying a lot of terms. Are there any questions? Is there any confusion right now? Okay. Also just a second to pause and not have to think for a second. Maybe I need it more than you guys do. Maybe you're doing just fine. So I say in breakout groups, let's go ahead and try that. So in breakout groups, I want you to come up with a multi-stage sampling design to determine opinions on coming back to school for the second quarter. And you need to make it representative, make it random, and make sure you have a big enough sample size. And after you guys come up with a multi-stage sampling design for this, we'll just talk about bias a little bit. So I'm just going to split you into three breakout groups so they don't get too big of a size. Who knows, maybe even 4. All right, so let's do that for just a minute. Now looking at bias, and this is kind of the last thing in this chapter that we need to discuss. And bias is anything that makes a sample not represent the population. And it can be in the sample design or it can be in the survey design, like the actual questions that you ask. And we already talked about convenience sampling and what's the other one? Voluntary response. Those are both no-nos, and we talked about reasons why there. Under coverage, this is where you think you're having good design, but you could still do under coverage when you just don't include some segment of the population in your sample at all. So of course, if we just completely skipped over freshmen as we were doing a survey of the school, then that would be under coverage. So there can be many reasons for under coverage. Sometimes it's intentional. So if people who are kind of manipulating their results, and so they leave out some of the population, but that's actually not as common as you think. A lot of times it's unintentional. So let's look at this example. A statewide survey is sent out to carefully selected homes, but the sample design doesn't include PO boxes. Therefore, anyone in the state who uses only a PO box is not included and they are underrepresented. There's undercoverage. All right, I'll go back to that. So, and I'll clarify this in the end because the next one's going to sound somewhat similar. So the next one is non-response bias. So some samples are well designed and you actually pick a representative sample and you reach out to everyone, but there's the results can be thrown off by non-response bias. So let's say that this survey from before was sent out to carefully selected homes, but the survey is only in English. So non-English speaking families don't participate and those families are underrepresented due to non-response bias. They got the survey, they were randomly selected, but they didn't respond. So therefore it's non-response. And one approach to correct for this is to opt for quality over quantity. And that means if someone doesn't respond to your survey, then you contact them and get their responses. You don't just say, oh, well, we'll just go with the data that we got. You actually gather all the data from the homes and people that you select. Okay, so just to clarify the difference between these two, if a person never responds to a survey that they were included in, then that is non-response bias. But if a segment of the population was never even included in the survey, in the sampling to begin with, that's undercoverage. So hopefully this helps to clarify. So undercoverage, I guess another thing to say is undercoverage happens in the sampling design. And this happens after the sampling design is done and you start getting your responses back. Okay. Okay, that's a good question. If you can't get someone to respond, would you have to find a different person? If you need a specific number in your sample, yes, you would have to replace them. But you also, ideally, that doesn't happen too much. You're never going to get 100% response, but you want to reduce the non-response bias. So you want to try and follow up with everyone that you selected first. And then if you still need to get like 20 more surveys to make your analysis effective, then you'll have to pick new people randomly. Okay, anytime you use voluntary response sampling or convenience sampling, it's going to be non-response bias is going to be a big thing because everyone technically was invited to participate. In voluntary response sampling, I should say, everyone was invited to participate, but only some people did. So the rest of them chose to not respond. I guess I should clarify this. Convenience sampling would be under coverage because that's just like, I'm only going to ask these people who are close to me. And so you're undercovering by not including anyone who's not close to you. All right, and that just says we're omitting people from the sample. So we can see some of this. Okay, response bias is kind of a broad thing. But if everything went well, you actually got responses from people, you didn't leave anyone out to represent the population, you can still get bias with what's called response bias. And maybe the actual survey had problems. And anyone whose response is biased in some way by the questions, that's called response bias. And this is just to clarify. If you don't respond to it, it's non-response bias. But if you do respond to it, but you give an answer that you normally wouldn't have given, or not responding to questions, okay, you can read what I'm trying to say. So if someone skips a question and they return their survey, that's response bias. So it's kind of a weird thing, I know. So we'll talk about why maybe some people skip questions. All right. So here are some common sources of response bias. Poorly worded questions. So if the question isn't phrased very well, people might change their answers based on how it's phrased. Intentionally biased questions. This can happen quite a bit. Nonverbal cues from the questioner. If you're actually asking people in person, but you're kind of giving them nonverbal cues, like you're really, really happy if you're talking about like, what do you think of this candidate? And you're super happy and like, what do you think of this candidate? And you're kind of like, this guy sucks, then those are some things that can sway people's opinions. So there you go. So like if you're also presenting yourself wearing campaign buttons while trying to get opinions on an election, that's going to change people's minds. Asking really personal questions when you're face to face will change how people respond. If I asked you right now a very personal question about your life, you are likely to not give me the full truth or maybe completely lie. So you want to be careful about that. Anything that you're trying to get very personal questions answered, you typically want to make that anonymous or somehow protect anonymity. Asking questions that require extensive background knowledge. So if I asked you questions right now on stuff you had no clue about, your opinions wouldn't matter because you don't have any background knowledge about it. And if you give leading information, so if I gave you a bunch of information and then asked you a question, but the leading information made it very biased, then of course the question is no good. But sometimes the information is not biased, and so it's okay. So that might be a little bit of a strange idea. This is kind of a weird thing, but there have been studies that have been done where they take the same questions and they change the order that they're asked in. And they can even lead to differences in responses based on the question order. So that's actually something that people will do. They will have the samples given in different question orders just to make sure that there's no bias. And you can kind of test for that after the fact. Okay, so I'm going to give you 3 scenarios and I want you to decide which of these have response bias. Does this question have response bias?
Yes.
All right, how does this have bias?
Because they're asking a question before they're actually asking the question at hand. Like they're talking about Barack Obama's, like they're making like a statement about Barack Obama before they actually ask about Donald Trump's.
Okay. And anyone else want to add comments to that?
It's just like you said before, when getting information beforehand could lead to a different answer of the question.
Yeah. So this is leading information, but I don't think this is presented in an unbiased way. So it seems when I read this, it seems like there's a bias in the questioning of this too. Probably bias to try and sway people to think that Donald Trump did a better job than you might have normally answered. All right. How likely are you to renovate your home in the next 5 years? Is there any bias in this question?
Maybe a little bit biased because I feel like the choices aren't very specific. Like somewhat likely and somewhat unlikely could kind of be the same thing in a way.
Okay. And that is fair. That's fair to, and I know kind of, yeah, that is possible. I would say in general, this one doesn't have bias. It doesn't, I think it's presented just very neutrally. Just tell me your opinion. But yeah, I do agree with you. You might not like the answer choices, but probably not bias here. Please rank the following heads of state in order of their effectiveness: Justin Trudeau, Boris Johnson, Angela Merkel, Emmanuel Macron, Xi Jinping, and Vladimir Putin. Is there bias in this question?
Yes.
How so? I will go ahead and tell you here, there is bias. So what is the bias in this question?
Like I don't know how to explain it, but like it's because it's asking about like two different equally like two different styles of government, because there's like very Eastern and very Western people on the list, so two like extremes.
Okay. So I think that's definitely a part of it. We're asked to do a very difficult comparison, and they're really reducing this down to maybe an unfair question. Is there anything else that jumps out? Let me ask you this. Who knows who Emmanuel? Order of the names could matter. Yeah, because actually that's a good point, because the order of the names kind of people create a natural order based on, oh, Vladimir Putin's at the end, so he must suck. But who can tell me the country that Emmanuel Macron is the head of state for? Okay, unless this has changed in the last few months, not that I'm aware of, he is the prime minister or president, I can't remember, of France. So this is the thing. This question requires, in addition to what you threw out, Aries, earlier, sorry, my son's name is Ari, so I just want to say Aries, but it's Aries. Anyways, but unless you know a lot about political science, this is probably a biased question because we don't have the background knowledge we need to answer that. And what else was I going to say? So this could be a fair question if you're going to a conference of political scientists and asking them, but otherwise, probably not. And then this last question right here, how much worse than the American Revolution was the American Civil War? So I had 4 samples for you. And this one is biased as well, I'll tell you that.
Because it's kind of already saying that they think one's worse than the other in the question.
Exactly. Yeah, there's already that presupposition right here that the American Civil War is worse. And so it's giving a bias in the question itself. Let's not focus on this too much more, though it is good to try and pick out bias in questions. And I believe in your homework, you'll have some of that. So maybe we're not going to do this in breakout groups. This probably isn't going to be too difficult. So can someone think of wording for a question that gives feedback? We want to find out if people want to come back to school. How would we ask that question so there's no bias?
Like just the wording of the question?
Yeah, just the wording of the question. Yeah.
If you just said, do you want to come back to school?
Yeah, this one is not a super difficult question to get the wording right. Maybe we phrase it slightly different, but I don't think that had any bias in it. How comfortable are you coming back to school after the 3rd quarter? Very comfortable, not comfortable at all, ... All right, I'm not going to spend any more time on this. We need to wrap this up. Okay, one last thing about bias. We talked about sampling variation. And if I pick a bunch of different samples, it's going to include different people each time. We know that. So we're going to get different results. And that is called sampling error. This is not a form of bias. It's called sampling error, and it's not a very good name for it. Sometimes sampling variation is used, and I use that right there. It is a natural part of sampling design and cannot be avoided. So the fact that I took 2 samples and I got completely different results, if everything else was good, that's just a natural thing that happens. So the sampling error, you know what, we're going to dig into sampling error a lot more later in this class, later in this semester. but I just wanted to point it out. Sampling error is not bias. It is natural. It cannot be avoided. Okay. So that is basically it. I just wanted to make that point. Here's your homework. I kept you right up to the bell today, the metaphorical bell. So thank you for sticking around. If you have any questions, you can still stick around, but otherwise have a wonderful day and I will see you tomorrow.